So in this video, we're going to be talking about how do you take a function and find the inverse of that function. So in the last video, we talked about how you can find, how you can take a relationship, so a set of maybe coordinates, and then reverse the x and y's to get the inverse relation. But how do you take an actual equation or a function and find the inverse to that? And it's actually pretty simple. There are 4 small steps you can do. What you have to do is most of the time functions have the f of x instead of y. So what we do first is we replace the f of x with y just to make this a little bit easier for us to solve. But just as a quick reminder, f of x is another way we can represent the y on a graph. And so in this case, the first step is always to switch the x's and y's. Let's go ahead and do that there. So this f of x is now y, and we have 3x plus 4. So that's step 1. Step 2 is to switch the x's and y's because that's what it means to take the inverse. So if I switch x's and y, this y is now an x, and this 3 now has a y next to it instead of an x. So now I've taken the inverse. The only thing is, notice how y is not by itself. I want to know what the inverse function is, so I need to try to get y by itself again. So the third step is to solve for y or get y by itself. So that means if I want to get y by itself, I need to move over the 4. So I'm going to subtract over this 4 here. So that would cancel. X minus 4 would come down, and this is a 3y. Now from here, I need to get rid of this 3, so I'm going to divide off a 3 to cancel. And there we go. So that means that my equation, let me write y in front so it looks a little bit nicer. So y is by itself. I'm going to just put it in front. It looks like I'm dividing by a 3, so just divide each term on the top by a 3. So this x here technically has a 1 in front, so you have 1 divided by 3x. I like to put the coefficients in front of the x so it looks a little bit cleaner. And then 4 divided by 3 is going to give me 4 over 3. And there is our new equation. But the last step is to replace the y with the inverse function. Because the original equation started out with an s, we need to claim that this is the inverse. So we use that symbol to help remind us that this was the inverse equation that we found, or the inverse function. And that is our inverse. So it means that basically if I have the original equation and now that I found the inverse function, I can plug in whatever x value I want and I'll find the inverse y value. All right, so let's take a look at example 2 here. So we're going to practice this method and it's pretty simple. It's just those 4 steps. So I'll kind of show that into the view here. So step 1, we have to replace f of x with y if it's not already replaced. So this f of x is really a y. And then step 2 is to switch the x's and y's. Notice that when I switch the x's and y's, I don't move coefficients, right? Like that -2 is still on the right side, and it's just x on the side. So the only thing I'm switching is the x and y's, nothing else. Nothing else moves. From here, I need to get y by itself, or I need to solve for y. So I'm going to move over the 7. So this is x minus 7 equals -2y. I'm going to divide over a -2 to get rid of the -2. And then the y is equal, so y is now by itself, so I'm going to bring it down. I like to write my y's on the left side when it's already by itself. It just looks like a normal equation to me. And then this x here has a 1, so I'm dividing it by -2. So this is going to be -1/2 x, and then -7 divided by -2 is a positive 7 over 2. So here's my new equation, but don't leave your equation like that. Remember, this is not your original equation. It's not y anymore. It's the inverse function because you switched it. So your inverse function is -1/2 x plus 7 over 2. And there we go. We have our inverse function. Okay, now that we have somewhat of the steps down, let's go ahead and practice a little bit more to try this out on different equations. So this one is an x squared. We're going to try to remember how do we take care of x squares. But first, let's do step 1, which is to replace f of x with y. And then what we do is we switch the x's and y's and then solve for y. By the way, I just want to mention, once we start getting into things, you might be asking, can I just skip from this step and just down to this step? And that's totally fine. So some students will know that f of x is a y, and so they just go ahead and switch it early without doing this middle step here. And that's perfectly fine. But in this math, I will show all my work just so that no one else gets lost. So I'm going to subtract 3 over to the other side, and this will be x minus 3 equals y squared. And from here, I need to get rid of a square. And the way I get rid of a square is I always take a square root. So this might seem familiar now. So that helps you get rid of the 2, but you have to square root the other side. And so this y comes down, and this is going to equal the square root of x minus 3, whatever I have on this side. Now, some of you guys are going to be thinking, oh, I need a plus and minus sign in front. But I'm going to tell you right now, when you're taking inverse function, you don't want to write a plus and minus sign in front. This has to do with mathematics that inverses don't like positive and the negative version. It has to do with a graph, and it gets really complex. So I'm going to try to break things down a bit. Basically, when you graph something that's a square root, it's going to look something like this if it's positive. But if you count the negative, it's going to go downwards too. It's going to reverse itself and flip. And there's a rule with inverse functions that it can't, if you were to do a vertical line test, it would hit in 2 places, so it would fail the vertical line test. A vertical line test helps you determine if something's a function, and if something hits it twice when you do a vertical line test, it would fail. So basically, the moral of the story is when you're taking the inverse function, don't worry about writing a plus and minus sign in front. Just always use a positive version. So I thought I mentioned that with square roots, I know we get a plus and minus sign in front, but in this case for inverse function, don't write a plus and minus sign, just use the positive sign. If you have questions about this, I'm more than happy to explain this in detail in class or through an email. So let me know. So this y here is not our y, it's the inverse function. So we have the inverse of positive square root of x minus 3 as our final answer. All right, let's take a look at our next one here. So this one's a cube, x to the third power. So let's see how we handle that. So this one has a g of x, but g of x, f of x, they're all the same here. They're going to be our y, and then we just need to switch our x and y. And then solve for x. So I'm going to add 5 over to the other side. That cancels. X plus 5 comes down, and this is y to the third power. And to get rid of y to the third power, is a little bit tricky, but all you have to do is take a cube root. So like what you would do with a square root, you take a square root when you see an x squared. With a cube root, you take a cube root, and that helps you cancel out the powers. And so I need to take a cube root on the other side here. And so y comes down as itself, and then you have a cube root of x plus 5. And now, the thing about cube roots is you don't have to write a plus and minus. I know this is inverse functions, but cube roots don't have a plus and minus sign. Only square roots or even roots. But odd roots or cube roots, they don't need a plus and minus sign. So from here, our inverse function is the cube root of x plus 5, and that is our final answer. All right, moving on to the next one here. This one we have a fraction, so we'll see how we can handle this one. But again, I need to rewrite this with a y and then switch my x's and y's. So that's step 2. So step 1 is to replace the function notation with y, and then step 2 is to switch your x's and y's. Step 3 is to get y by itself. So maybe I need to move the 5 over by adding it over. That would cancel. And so I'm left with x plus 5 equals 1/3 y. And now I need to get rid of this fraction. So there's many ways you can do this. You can divide by 1/3 on both sides, and that would do the trick. A quicker way is actually to multiply by the reciprocal. So if you have a fraction, if you multiply by its reciprocal, so the reciprocal of 1/3 is 3/1, that will help you cancel out the fraction because 1 and 1 are diagonally of each other, and 3 of 3 would cancel each other. So anything, that's going to be diagonal, but just watch. 3 times 1 is 3. So that'd be 3 on top already. 3 times 1 is 3. So 3 divided by 3 it ends up being a 1. So that's how they cancel. So this would cancel with this guy, leaving you with the y. But you multiplied 3 over 1 on this side, so you have to multiply 3 over 1 to the other side. But 3 over 1 is just 3, so I'm technically just multiplying the 3 over to the other side. Make sure you put parentheses around what you have on the other side, because when you multiply this 3, make sure you multiply to everything on the other side. So you have a 3x plus 15, and it looks like the y is now by itself. So this is inverse of g's function and 3x of 15, and that's my final answer. Oh, speaking of g of inverse, I don't think I wrote g of inverse on the other problem. My bad. I meant to write this as a g. There we go. So sorry about that. I meant to write g inverse. Since this started out with a g, I want to end it with the g. But that is it for this video. It looks like we found all the inverses. So feel free to try some out the practice problems to practice more of these same skills.